Hello students, welcome back. In this part, we are going to learn about how the rate of a reaction is related to concentration of the reactant species involved, and also about how rate constant of a reaction is defined. So let's start with the presentation.
Now let's discuss about how the rate of reaction is related to the concentration of the reactants. So this law of mass action will give the rate of reaction, the relationship between the rate of reaction with the concentration of the reactants. So according to law of mass action, so at a given temperature, so rate of a reaction at a particular instant is proportional to product of the active masses of the reactants at the same instant, which are raised to the powers which are numerically equal to their stoichiometric coefficients. So at a given temperature, it says that the rate of reaction is proportional to, say, active mass. Say active mass A is the reactant, then CA represents active mass of A, which is raised to its stoichiometric coefficient in the given balance equation. So this is, say, A, and say if another reactant is there, so active mass of B power B, where A and B are the coefficients of reactant A and reactant B. So to understand it better, let's take an example. So consider a simple reaction where A is giving B. So A is reactant and B is the product. If Ca is the molar concentration or active mass of A, then the rate of the reaction at any given instant, dx by dt, is the rate of reaction which is proportional to active mass of A at that same instant. So here if we introduce one proportionality constant, so dx by dt is equal to k into Ca, which is the active mass of A, where k is known as proportionality constant or rate constant of the reaction. So this is law of mass action for a reaction, for a simple reaction which is A is giving P. So if you talk in general, so let us consider a general reaction. So this is a general reaction. So according to law of mass action, the rate of this reaction is equal to K into, which is a rate constant, into, this is the active mass of A. This represents the active mass of A, which is raised to the power A, where A is its stoichiometric coefficients, and similarly active mass of B power B, stoichiometric coefficient. If you see the exponents here, A and B are equal to their stoichiometric coefficients. So this is according to the law of mass action. So now I have used a term that is active mass of the reactants. So what is meant by active mass of the reactants? So active mass of the reactant is nothing but it is the molar concentration of the substance. So molar concentration, we already know that molar concentration is equal to the number of moles of the substance dissolved in 1 liter of the solution. So number of moles divided by volume. So if here the volume is taken in liters and number of moles are N. So N by V represents the active mass of the substance. So this is about law of mass action, which expresses the relation between rate and the active mass of the reactants. Active masses are molar concentration of the reactants. Yeah, this is a theoretical law, which is this rate expression is directly deduced from the chemical equation. So now what is rate law? Rate law is also a relationship between the rate of the reaction with the concentration of the substances, concentration of the reacting species. But here it is the actual relationship. This is the actual relationship which is derived experimentally. So let's take some general reaction where A and B are the reactants, so giving products C and D. So the rate of this reaction as per the rate law is equal to K into the concentration power X and concentration of B power Y. So if you see here, this X and Y are the exponents which may or may not be equal to the stoichiometric coefficients. Sometimes they are equal, but sometimes they are not equal. So it is not necessary that the X should be equal to A and Y should be equal to B. That is not so. because it is determined experimentally, which is not directly deduced from the given equation, given chemical equation. So here this X represents the order with respect to A. So the reaction is X order in A and the reaction is Y order in B, and overall the reaction is X plus Y order overall. So I'll discuss more about this order in next part. So this X and Y represents the order of the reaction with respect to A and with respect to B. So X and Y. So this is the actual relationship which is determined experimentally. So rate law is an experimentally determined relationship between the rate of the reaction with the concentration of the reactants. So let's discuss more about this rate law. So let's take an example, one more example. So in this example, F2 is reacting with 2Cl2 and it is giving 2FClO2, which you can see here. This is F2 molecule and this is ClO2 molecule. So 1 mole is reacting with 2 moles and it is giving 2 moles of FClO2 molecule. So the rate of this reaction is expressed as the rate is equal to K into concentration of F2 into concentration of ClO2. If you see here, it is 1, but the ClO2 stoichiometric coefficient is 2, because this is experimentally determined. Here it is not equal, but here this 1, it is 1 and it is also 1, so which is equal. So one exponent may be equal to the stoichiometric coefficient, other may or may not be equal. So here it is equal, but it is 1 and it is 2, which are not equal. So but the law of mass action for the same equation can be expressed as rate is equal to K into, which is directly deduced from the chemical equation. So just by looking at the balanced equation, you can write the law of mass action, which is K into F2 into ClO2 square. So here law of mass action and rate law both are different. And the order of a reactant is not related to the stoichiometric coefficient of the reactant in the balanced chemical equation, which I already explained here. Sometimes they are equal, but sometimes they are not equal, but it is not necessary that they should be equal always. So this is about rate law. Let's see the differences between rate law and law of mass action. We learned about both law of mass action and rate law. So what is the difference between them? If you know the difference between them, then we can clearly understand what is rate law and what is law of mass action. Rate law is an experimentally observed law. So they conduct experiment, they observed that how the rate is, they calculated the rate and they calculated the concentration of the reactants and they deduced this rate law, which is an experimentally deduced one. But the law of mass action is a theoretical one, which you can write directly from the given chemical equation. Here it depends upon the concentration terms on which the rate actually depends. So it will give the actual relationship between the rate and concentration of the reactants. But whereas the law of mass action, which is based on the stoichiometry of the reaction. So if you take a reaction of this type, with A and B is giving products. So for this reaction, the law of mass action is, you can write directly from the given chemical equation based on the stoichiometry of the reaction. But you cannot write rate law in this fashion. And though you know the stoichiometric coefficient, but this X and Y may or may not be equal to this A and B. So until and unless you determine experimentally, you cannot write a rate law expression. It should be always experimentally determined one, which is the actual relationship. So this is about the difference between rate law and law of mass action. Now let's see what is a rate constant means. Yeah, if you consider a simple reaction, and Ca is the molar concentration or active mass of A at a particular instant, then the rate can be expressed in this fashion. So here K is known as the rate constant or specific rate, which is defined as when the concentration of the reactants are equal to 1, then the rate of reaction will become the rate constant. So if Ca is equal to 1 here, if its molar concentration or active mass is equal to 1, then the rate of the reaction is nothing but the rate constant. So which is defined as rate of a reaction at unit concentration of the reactants. Like if I take one more example, say rate of some particular reaction is equal to K into say concentration of A power x and concentration of B power y. So when concentration of A and concentration of B, if both are 1, then the rate of reaction at unit concentration of the reactants is nothing but the rate constant of the reaction. Here there is a difference between rate and rate constant. Don't take both the things are equal, but they are different. And this rate constant is going to depend upon temperature and nature of the reactants as well as catalyst. So these are the three factors which will affect the rate constant of the reaction, but it is independent upon the concentration of the reactants. Whether you take 1 unit concentration, whether you take concentration different, the rate constant is going to be same, which is independent upon the concentration of reactants, which only depends upon the temperature and the nature of the reactant and catalyst. So these are the three factors that will affect the rate constant. So this is about rate constant and rate law and law of mass action.
While studying this chapter, if you get any doubts, you can post it for free on askIITians.com. How? First open the website, and if you see at the top right, you will see a discussion board. So simply click on that. It will take you to the next screen. Yeah. In the next screen, you will see the Ask Experts, a separate section on the right hand side. So select a relevant category for your question and simply post your question here. We experts at askIITians will provide answers to your questions within 24 to 48 hours. So students, in this particular part, we learnt about law of mass action and rate law, and we also discussed about the differences between those two, and also about rate constant and the factors which are influencing the rate constant. So in our next part, we will discuss about order and molecularity of a reaction. Stay tuned in.